So in the last lecture, we looked at this new tool called the square root method for solving quadratic equations. And it's one of those tools that it looks great in theory, but not so much in practice because equations don't usually look like something squared equals a number, which is what that method requires. So what I want to be able to do is I want to be able to take just kind of a random quadratic equation like this thing I've got right here and manipulate it. I want to add something to it so that this ax squared plus bx part becomes a perfect square. I don't really care so much about the c, all right? Because you'll see when we start doing these examples of completing the square with real equations, the first thing I do is I move the c over to the other side and forget about it. I complete the square on the ax squared plus bx part and then add that to both sides. So here's what I want to do. I'm going to start off with ax squared plus bx. And I want to add some number k to it that makes this into a perfect square, that makes it into mx plus n squared. All right, so first I want you to keep clearly in mind what our goal is here. I'm trying to find k. I want a formula for k that uses just a's and b's because those are the numbers when we're looking at an actual quadratic equation that I know. Okay, so here's what I'm going to do. I'm going to multiply out this right-hand side. This is mx plus n times mx plus n, and I'm going to do a little FOIL thing here. And this is going to become m squared x squared plus 2mxn plus n squared. All right, so now here's the thing, all right? And this still equals ax squared plus bx plus k. Now I'm going to rely on here as this definition, this idea of what does it mean for two polynomials to be equal. All right, well, if two polynomials are equal, that means that kind of their corresponding coefficients are the same. Their x squared coefficients are the same, their x coefficients are the same, and their constants are the same. All right, so in other words, a is equal to m squared. Those are the coefficients of the two x squared terms. And b has to equal 2mn. And, most important, k has to equal n squared. All right, so remember, I'm trying to find a formula for k, so that n squared part is what I'm really interested in. So how can I get rid of this, right? I don't want an n. I want a's and m, or a's and b's. So, okay, look over here. This is almost it, right? N is equal to b over 2m, which is nice, I guess. I mean, we're halfway there. Now I've got n in terms of b, but that m has to go. All right, look, come over to the first equation. Take the square root of both sides of this. M is equal to the square root of a. I know, plus or minus. Oh, okay, let's put the plus or minus. It's not going to matter in the end, but hold on to that. Now, I'm going to put that into here. N is b over plus or minus twice the square root of a. That's what I needed. Put that into here. K is equal to b over plus or minus 2 times the square root of a squared. Now you see why I didn't care about that plus or minus? Let's simplify this a little. This is b squared over plus or minus 2 squared. Plus, minus, I don't care. 2 times 2 is 4. Negative 2 times negative 2 is 4. Square root of a squared is a. There's my special number. Right? And you'll see this. We're going to do a bunch of examples in the next lecture in the series. Every time I have to simplify or do completing the square, all I'm going to do is I'm going to use this formula, right? Put my numbers for a and b into there, add that to both sides, and the left-hand side is going to turn into a perfect square.